welcome to this presentation on creating concrete stairs and railings in advanced steel. So my name's Alex Giles. I'm one of the technical consultants at Graitec. Most of you know me, I think, and we're going to discuss these techniques. We see a lot of people doing concrete stairs and obviously the railings that go up those stairs in their advanced steel models, and we see a variety of ways of approaching it. So we thought it might be useful to show you how we would approach it to be as efficient as possible. This webinar is part of a series of webinars. You just missed one the other day for how to do some timber modeling in advanced steel. There's a recording available for that. Then you got two from me today. This is the first one. I'm also doing custom connections later on. Revit and advanced steel, Plant 3D, and some other things. The links will be available in the handouts later on. I'll go back to this slide. So here's a picture of the model we're going to create today. So like I say, lots of people seem to do the concrete stairs, but they don't always do it the way we would recommend. Might be having some trouble. And we thought it would be useful to present to you how we would approach it to be as efficient as possible. The first thing I'm going to do is model the stairs themselves. So the concrete slabs here, or stair, there's several ways we've seen people doing it. I'm going to model them. I'm going to place some slabs around it, obviously, just to create a realistic kind of starting point. That's the first bit, some tips on that. But then we're also going to put the railings all around those. As you can see, we're going to do all the connections between those railings, and there might be some things there you've not thought about. And we're going to connect those railings to the concrete as well. So there's a few different things going on, and while I do all those things, I'll be doing some small little tidbits and little tricks in the way as we go through. So the whole thing should take about 40 minutes from scratch. If you've got any questions as we go through, you should be able to enter them into the questions panel on your GoToMeeting interface, or perhaps just the chat panel if it's not working on the questions. Put them in there and I'll have a review of those at the end. But let's get on with some modeling. So here's my advanced steel. As you can see, I've got no file open at the moment, so it's no cheating. I'm starting straight from a blank file. So I'm going to start with my template. And away we go. Now, whenever you're modeling stairs, we always recommend you have to know where the nosing line goes, top to bottom, or bottom and top. So I'm going to do that with some construction lines. Just simple, ordinary AutoCAD 2D lines. Start in the middle of the universe, of course. So my stair flight is going to be 2,300 long and 1,500 high. I need the landing. Then another flight of stair. And the final landing. Okay, so I'm going to put a great big base slab around that. There we go. Now for the stair, we see people do this as slabs, sometimes as beams, but they don't seem to ever quite do it quite the way we would recommend. What's the fastest way? We need to use beams, because then you can put the railing straight onto a beam. So you definitely don't really want to be using slabs in any way. If we just use a straightforward concrete beam, I can then draw it from the bottom to the top of my construction lines. Give it the right size. Get it in the right position. Like so. Then I'll put a slab on. Oh no, let's do another beam first. That's ready for our top flight. I'll put a couple of landing slabs in there. So rectangular slab there. Oops, Remember to move the UCS first. Okay, so we've got the simple shapes. Now we make them look like stairs. So first thing I want to do is trim off the top and bottom of these. Go back to world. Put the UCS on the corner here. Make sure I turn it around, of course. I'm just using shorten at UCS rather than trying to do anything too fancy. Remember, the concrete only exists to put the stairs on and put the railings on, more like. The precise fitting of the concrete around each slab is not important to us. We're not designing the concrete, so I wouldn't waste time trying to model exactly the right interface between the two pieces. It's not really necessary. That's your call, of course. Okay, so we've got the basic trimmed off concrete. It's not going to look too horrible. So now we've got to cut the treads into that. So we put the UCS back, start on world, tip it up. We need to make sure the UCS is on the side of our beam. And then once it's on the side, you can simply use a rectangular contour by 1 point to cut a shape out of that. So you need to know the going and the rise, and put that in the corner of the cutout. That's one thread. Then we can use transform elements on that one step to cut the rest of the treads. Simply a rectangular pattern or copy with that transform elements. Repeat that on the other flight up here. So move my UCS to the bottom of that flight and turn it around. Rectangular contour by center on the side of the beam at the bottom. Make sure you get the positioning in the corner. Then you can use transform elements again. The only thing you need to select is the feature. You offset from one corner to the other with the right number of treads, and you get your stair shape cut in it. That's an extremely quick way to make the stairs. No messing about drawing fancy great big polygon contours with all those steps drawn in individually. That's a bit laborious. This is much easier. You can always copy an extra 1 or 2 if you guess the wrong number, and so on. Very quick and easy. So that's the stair. Straightforward and simple as that. Let's hide the features so we can see a bit neater what we're doing. And now it's time to start with the railing. Got a couple of questions already. Let's make sure there's nothing drastic. Okay, I think everything's safe. In order to do the railing, because we've used beams here, we can put the stair railing straight on there, but we can't put railing on a slab. So I'm going to have to draw dummy beams around the slab. So I'm just going to use flat bar. So I'm going to draw it from corner to corner on the slab. Let's go back to world coordinates before I do that. So I'm just going from corner to corner on the slab. I need one in here as well for the small piece of railing in there. I've got an end point here I can start at, that's easy. But I only want to go across as far as this stair, and I've got no end point in line here. But if you look at my UCS, it's the Y direction I'm going in. So what I can do on the UCS palette, I can click this button saying .Y. That means I'm only interested in the Y direction for the next point, and then use an end point on this side of the stairs. And even though I picked down here, it's ignored the X and Z and only chosen the Y, so it's gone to exactly the right point up there. It's a great little command using these point filters, .x, .y, .z. They're very helpful for lining things up. And once again, I'll do the same for this stair. So .y to an end point here, and it just lines it up in line with the first 2 points. So that's all my dummy beams. Now all of those need to be, I'm going to make them quite big. It doesn't really matter what size they are because they're not going to show anywhere, but I want to be able to see them and pick them easily. Positioning can go on the, is it inside or outside? Inside corner. There you go, make sure it's inside so it's on the right position with the slab. And that's fine. Now, because they're dummy beams, I really don't want them to show anywhere, obviously. So the first thing is, on the naming, if you actually set the model role to not visible, all the GA views will automatically ignore that object and will not draw that object. So you won't get the dummy beams showing up in all the GAs and having to try and hide them or delete them later. They simply won't be drawn in the first place. And then naturally, I don't want them to have a part number or show on any bills of materials either. So I'll remove these ticks from the behavior tab. Now they're completely dummy parts. They will never show on any drawing or any output. So we're ready to start creating the railings proper. So I'm going to start the first bit of railing here with the handrail macro. And the beam I'm going to put it on is that first flight. And I'm going to use the ends of the system line for its start and end point, and I'm not going to worry about a nosing line for this one. There's no offsets from the nose. Because it's a beam, the railing succeeded. It automatically, no matter which points you choose, goes up the center line of that beam. That's fine. As long as we know that, we can work with that. So now it's a straightforward railing. So you know most of the things about railings, I imagine. First thing I'm going to do is move it to one side. So I'm going to want this one on the right hand side, and I want it outside the concrete so it can bolt to the side of the concrete. So the concrete from the center line to the edge is 600 because it was 1200 wide concrete. Then I've got to allow half the post, and the post is 42.4, so I'm going to allow 21 for that. And then I also want to allow for the plate. I'm going to use the palm plate, which was 10 thick. So that's 631 in total. So is it minus or is it plus? I got it right first time. It's minus this time. So minus 631 has moved it to the right size of the beam. So checking out the other bits and pieces, we really want to make sure that the posts are in the middle of the treads. Because this is going uphill, all these dimensions are currently measuring uphill, and you're never going to get anywhere like that unless you love doing trigonometry. So always make sure you tick this, use horizontal distance on slope, and things will make a lot more sense. My going was 230. If I want the post in the middle of the tread, then I'm going to use 115 offset. Okay. I'm not going to fuss around too much about the other bits. The height on the stair should be 900. And then the middle handrail 450. Don't really want a kick rail on the stairs. Let's put a loop return on the bottom of the flight, so that should be 450 high. Okay. So that should be all we need there. The stairs divide up, so these middle posts are also in the middle of the tread, so that's good. So I'm happy with that. You can see it's on the side of the stair. And I haven't had to do any fudging or any manual railing at all. It's all still macro driven. So happy with that. Not going to put the stair fixing in, post fixing in the macro, because that hasn't got anything that's going to work appropriate for concrete stairs. I'm going to put the railing around the platform or the landing now. So of course I'm going to choose these beams as the supporting beams. Because I can't put it on the slab, I have to put it on my dummy beams. Start here and over there. No nosing point. Okay, now this time again it's come up in the middle of the supporting beam, which is 10 thick. So to get it on the edge, it's half of the 10 thick, that's 5, half of the post, that's 21, and the 10mm for the base plate, so that gets offset 36. There you go. And just to touch that up a little bit, I'm going to remove that because I don't want too many posts in there. Okay, now this first post, when I project these sloping rails up to meet these, that post is going to get in the way, so I'm going to move that post along a bit. So I'm going to do that with 200 here, like so. Now we've got the kick plate that needs to go on the other side of the post, and because I've moved these ends, I need to move that back up to there, and then this end I could extend that across the bottom tread. So for the start, that'd be 200mm extra, and for the end that's 230 going, so that'd be 230 extra. Okay, I think I prefer that as continuous actually, not that it really matters. Right, so that joint, let's go for the corners as well, tidy them up. Let's go for radiuses. There you go, looks nicer. Great, so I've got my first two rails created. So now remember that the rails, we call them macros because they're no input beams, but essentially they are joints. So if I want another one exactly the same, I can use joint copy. So I'll use joint copy on the sloping rail to put it on this upper flight, and I'll get exactly the same. And then I'll use joint copy on the landing flight rail to go around those beams there. Don't need the nosing point. That's done. Right, so obviously they need a slight adjustment for their new position, so let's go for the sloping one. And I obviously don't want this loop on the bottom anymore, so I'll leave that on none. Now we need to make sure, again, we're going to extend these horizontal rails out to meet the slope, so that bottom post is in the way, and I need to make sure I have some middle rail sticking out there. So I've got to just touch these up a little bit. So when you turn off the loop, it doesn't turn on the middle rail again. I just need to make sure I set that back to normal. And on the post positions, I want to move, make sure it's horizontal distance, the start base point 230. Like so. For this top rail, I think that looks alright this end. Don't want it sticking out that end like that. So I just need to chop that end bit of the kick plate off again, this one. Like so. Okay, so that should be fine for all of those. Yep. Looking good. So let's hide the joint boxes, they're a bit messy. Now I want to put the radiuses in here, so I can just use a connection bolt down to miscellaneous, and you got railing joint handrail. I'm going to go between that rail and that rail, and I want that to be a radius. Don't really want it 150, that's a bit too big. I'm going to reduce it. And notice that it puts both as shop rails. We don't want all of that huge thing as one piece. So we've got to be careful here and make sure we remember to set one of them to sight. So I'm going to put the first one to sight. And now I've got that in there, I can use joint copy that joint like so. And just go round like so. So that all looks good. That's the outside rails done. I'll put the feet on later. Now we're going to do the inside rails. So again, similar really, they're just still pretty easy. So I'm going to start with the rail macro. I'm going to put it on this beam, and again use the nosing line, system line of the beam as my points. Don't need the reference point. Comes up in the middle again. This time I want it on the other side, of course. I'm going to bolt this one on top, so you see two variations. So I don't want to go all the way across, I only want to go 50mm margin on the edge. So that's 550. Okay. And then, just like before, I'll adjust a few bits. So I turn off the kick plate. Oh, don't forget to change the height. 900. And the sloped rail would be at 450. And the start of the rail would have her loop return. Okay, that looks alright. And I'll do one on the dummy beam here for the landing. Right, once again, this starts off on the centre line of that beam, which is 5mm in from the edge of the slab. So I only need to move this one 45. I'm going to make that kick rail continuous, and I'm going to put it on the other side of the beam. Right, now this time for the start and end points, I started on the dummy beam and ended on the dummy beam, but to line up with this rail I need to be 50mm further, because this rail is 50mm in from the dummy beam. So actually I'll go back to the posts and I'll add 50mm to either end of the rail, so that this corner lines up with this sloping beam. Now, to get a nice joint in here, it's quite very common to use a swan neck, so I need to have the vertical piece in there. Now you can actually get that for free by setting the end of handrail to a down stand. Looking at this though, it's pretty close. I'm going to shorten that down stand to make it so it's not too long and going past that middle rail. Don't want to cause any confusion with the other joints. Again, I'll leave the connections on the post connection because that's going to come later. There's nothing in the joint. It's assuming it's for steel beams, so it's using bolts. We need to use anchors into concrete. Okay, so I can do a joint copy on those two again. So joint copy that one for the stair. Okay, and joint copy the landing one onto this beam. Like so. And again, they're obviously going to need small adjustments. So going into this second flight, I shall turn off the loop, make sure I've got some middle rail, and once again, if you look at how that's connecting, we've got to make sure that these are going to link up somehow. So this needs to turn around the corner a bit horizontally and then join up with this coming down the slopes. That's going to be over here somewhere, so I need to move that post up at least one tread. So on the posts, I'm going to move that start base point minus 230 again. Yep. Okay. On the top one, that's lovely, but of course we add the extra 50 on this end. We don't need that this time, so I'll just take that off. So that's finishing in the right place. So I will need these two horizontal beams for the middle rail and the slope top rail from here. So I'm just going to draw a beam. It doesn't really matter what beam I draw. Just go, let's say 500 back. And another one for the middle rail. Let's make it a bit shorter, 300 should be enough. And then we can use the plain old simple AutoCAD match properties, which you can find on the tools ribbon, to get that beam to be the right thing. So it's a landing rail. So I'll choose a landing rail as my example. And it'll copy across as many properties as it possibly can. Layer, color, section, and so on. That's done for that one. Repeat that for the middle rail. And that's done for that. Wonderful. Now we've already done pretty much all the hard work. There's not much left to do. I'm just going to get that railing joint again with that small radius and use that to touch up everything else. So literally I can go from that middle rail to that down stand, and that creates my swan neck. I can do the same for these pair. There you go. There's the swan neck finished. No nightmare of drawing polylines and trying to get 3D curves or anything like that. Just do these to the horizontal portions, and then likewise onto the slopes. And coming up the top here, we'll do it again. Fantastic. So look at that. That's nice and easy, quick way to do these swan necks. Very quick connection there. It's all very neat and tidy now to get what you want. Let's just double check that one. I don't like the 4 posts there. That's better. Unfortunately though, changing that has upset this joint, so I'll just take that joint off again and do a new one. What about this end? Oh, they seem all right. Okay, so it's just one more joint copy. There you go. Okay, now the last step. Actually, I can get rid of some of my construction now, so I'm going to select all the lines. I do have a layer in my model that I've created called construction. Put that in my template file, and I can do the same for these dummy beams. Move them to construction. Turn that construction layer off. So the tools are still there if I need them later, but they're not looking horrible. Let's hide the joint boxes so I can see a bit clearer. Wonderful. Now, like I say, the last step we need to do now is to put on the base connections. Now, there's nothing in the connection vault that's going to do this for you spot on. So what we recommend is you spend a few minutes putting together exactly what you want for a palm plate in any shape you like. Be a bit careful about how you create it, and then use a custom connection. So custom connections are a topic on their own, and guess what? That's my webinar later today, how to do custom connections. So I'm not going to go into full depth now, but I have already created those custom connections. So I use insert custom connection. You can see here I've got circular, rectangular, triangular base plates, palm plates, and a base plate. I'm going to use the circular one. I'll go OK. Just pick the post, put something on there. Now that's a bit far down. I'd like to lift it up a little bit, so I'm going to tick allow modification. And then by adjusting the length of this shorten, I can move that plate up or down to the point I'm happy with. I'm going to put one on the post here as well, because the offset is different on the landings than it is on the stair. So remember to allow modification again, and I can edit this shorten in my joint. Minus 100 should do you there. That's lovely. Now that I've got one of each of those, they're joints like any other joint, so I can use a joint copy to put them on elsewhere. Joint copy multiple doesn't work too well because there's not an intersection of two beams. It gets a little bit confused, so just ordinary joint copy is best. And also you'll see there's a joint box there inside my joint. So it's important that when you're doing the joint copy for a whole custom connection, you make sure you pick the blue box to be on the safe side. You will get away with other bits, but it's safest to choose the blue box. And then I can just click on the beams, or the posts in this case, that I want to apply that to. Go around here to the other side. 1, 2, 3. Lovely. Same for the landing ones. So joint copy. Make sure I get the blue box. And just go around picking all the posts. So you can see how this user connection is really saving massive amount of work. If you had to model these each time, manual on each one, it'd be a real pain. It's only going to be the same on every job, so even if you had to only model it once on the job and copy it around, well, why model it again on each job when you can have the joint there to place in seconds? So that's the palm plate. The last bit we need is the base plate for the other posts. So I can go into the custom connection, select base plate, or rail post base as I've called it, and again pick the post. I need to allow modification because you can see that that's gone too deep into the floor. So I might need to go wireframe in this case so that I can see what I'm doing. And in this case it's this little internal joint that has the offset, and I need to change that. So the rise of my tread was 150. I've got a 10mm base plate. That leaves, well, so half of 150 is 75. So subtracting 75 or putting 75 on the end of the column would put it to the base. But I need to allow for thickness of base plate. That's 10, so it's minus 65 I want in there. Hard to see in the wireframe, but it'll be the right value. Then I need to put one on the landing rail. So post base for that one. Allow modification, and well, 0 has the post ending on top of the slab, so I just need to allow for the base plate, so it's going to be plus 10 for the value this time. So let's go back to realistic so I can see what I'm doing. There you go, you can see the plate nicely on top of the slab. I think that one is as well. So now, once again, it's just a few joint copies to go around the whole set. That one hasn't got the, let's undo that. Got the wrong number of posts on this one as well. I didn't see that either. That's better. So now I'll copy that joint. Not doing anything right, am I? sure my posts are in the middle of the treads. Didn't say any of the right values. Right. That's better. Yes, that looks better. Okay, and lastly, the slab ones for the landing. And there you go. So you've got the whole 2 flights of stairs out of concrete, looking the part. So on all your GA joints, they'll look sensible. Like I say, I don't think it's really necessary to be too worried about these end fittings or connections. And then you've got the full set of rails with swan necks, with corner joints and so on. And finally, we used custom connections to place the palm plates of whichever shape and the anchor base plates with anchors onto this concrete all the way around. And it's very straightforward and easy to do. So I hope you've picked up a couple of tips there. Let's have another review of what we're doing. Let's have a look, see if anyone's got any questions. No, doesn't look like it, so no questions. So anybody raise their hand? No, that's all good. So if you do find any more questions, send them through to support.uk@graitec.com and we'll try and sort you out and help you out. We are indeed here to help you. So you may have seen something like this slide before. Most of you have had the basic advanced steel training, but it's important to remember that the basic training is only the start of your journey with advanced steel. It's not the end. After you've had the training, you want to get the technology implemented properly. So that means deal with bits about putting your own logos on the drawings and on the bills of materials, maybe setting up a couple of custom connections for you, making a few adjustments to the defaults on the system and so on to get it set up to do what you want as a company and give you that head start. Later on, maybe 3 to 6 months down the line, you can consider some further customization to the documentation. So we could do custom bills of materials for you. We could do custom drawing styles and adjust all that sort of thing for you. Or you can do some extra training, just some coaching. If you think I'm modeling this, but I might be doing it the hard way, is there any easier way? We can help you through some tricky aspects. If you want to later on, especially if you're a larger group and you're managing this for several users, you can have some guidance and we can show you how to do all the customization there is, all the different bits and pieces in the system, where all the databases live, what to edit in each database to do whatever you need. And particularly for larger organizations, we've got aids we can give you for collaboration, where we can share the settings between lots of users and using a batch file, or also there might be things like going in and out of other software and so on. We can advise you on that. So there's many other things you can learn later on. Just doing the basic training is not really the full story. So like we said at the start, this webinar is part of a series. So the timber in advanced steel was recorded last week. You've missed that one for live, but you can still get the recording. I've just done this one, the concrete stairs and railings. This afternoon I'm going to show you how to do custom connections, such as the ones we've just made, although not actually those two. And then we've got some others coming up for Revit and Plant 3D. Now if you look in the GoToWebinar panel, there are handouts there, so you can please feel free to download those handouts, or please do. And these links all link through to the registration or to the recording of that first one, so you can enjoy those webinars. And we hope you do get some information out of each one as we go. And thank you now for your attention. So that's it for this webinar. I hope you found it interesting, and I hope to see you again this afternoon. Thanks very much.